Let's solve this problem. Very similar to the homework, but this is already solving the Laplace transform used to solve differential equations. Okay, so let's start. Here, one advantage is that the initial conditions are both zeros. Well, that is one advantage because of this. The procedure is to transform this differential equation into the Laplace domain. So that means that you have to do the Laplace transform of the second derivative plus 2 the Laplace transform of the first derivative plus 2 the Laplace transform of y, and that is equal to 2 the Laplace transform of t. Alright, if you check your formulas, then the Laplace transform of the second derivative is something like this. S squared capital Y of S minus S y of 0 minus y prime of 0. That is only the Laplace transform of the second derivative plus 2 the Laplace transform of the first derivative S capital Y minus y of 0, and then plus 2 the Laplace transform of y is equal to the capital Y. We don't know what is the Laplace transform of y because we don't know what is y. The y is the solution, and that is actually what we are looking for. And in the right side, it is going to be 2, 1 over x squared. Okay, the initial conditions are inserted at the beginning of the problem, so this is 0, this is 0, and this is 0. Okay, so what you get is these three numbers, where you can make a factorization. S squared plus 2s plus 2 times capital Y, and that is equal to 2 over s squared. Okay, a checkpoint here. Check that the coefficients here, 1, 2, and 2, are the same coefficients as this, 1, 2, and 2. That should happen in years. If that doesn't happen, then you did something wrong. Okay, now let's clear the capital Y. The capital Y is going to be equal to 2 over s squared plus 2s plus 2. Okay, so now to find the solution, what we have to do to find the y is equal to the Laplace inverse of capital Y, which means that we have to make the Laplace inverse of this to find the solution. And this is why we saw the partial fractions for the Laplace inverse. Alright, so we have to do partial fractions of this. Okay, so let's do it. Let's break here the problem because the next is partial fractions. So it's going to be 2 over s squared plus s squared plus 2s plus 2, and the partial fraction will be something like this. Okay, the first root is equal to 0 and the second root is equal to 0. It is repeated root because of this s squared. And what about this one? The roots for that is s3 and 4 is going to be minus 1 plus minus I. So that is the root of that number, of that part. Alright? So you can check this number by using the chicharronera, but the partial fractions will be something like this. A over s plus b over s squared plus cs plus d over s squared plus 2s plus 2. And remember, engineers, here what happens here is that you have this repeated root, so you have to write twice this, and you cannot make s equal to 1 and s to the power of 1 because that will be the same fraction. So this one is actually number 2. Alright, square. Okay, so if we do the common denominator, what will happen is that the numerator is going to be 2 equal to, the common denominator is this one, sorry, this is a multiplication, So it's going to be this divided by this, s squared plus 2s plus 2 plus b times this divided by this times b is going to be b s squared plus 2s plus 2, then plus cs plus d times s squared, because this divided by this times this cancels, and the only thing left is s squared times this number. Okay, now let's use the Heaviside method. To find the Heaviside method, let's use the first s equal to 0. But because it is repeated root, then the only number that you are going to be able to calculate is the value of b. Okay, so let's find it. So b is going to be equal to, for this, you consider this fraction, and it's going to be 2 over s squared plus 2s plus 2. And then evaluate in s equal to 0. So what is the value of b? 2 over 2 is just 1, because these are zeros. Okay, so we found the value of b. Okay, this number. Let's use the Heaviside method to find the other two, cs plus d. Okay, so cs plus d is going to be equal to, if you consider this, then you consider this fraction but without this, so it's going to be 2 over s squared. Okay, and then you evaluate in s equal to minus 1 plus I. Okay, so what happens here? So what happens here is that 2 over minus 1 plus I squared. Alright, so let's develop this square. So it's going to be, actually this square is the same as minus 1 plus I, and let's do the multiplication to see what happens. 2 over minus times minus, 1 minus I, and then minus I, and then plus I squared, but remember that the I squared happens to be minus 1, and this cancels with this, so this is equal to 2 over minus 2I. I can see that the 2 cancels. And how much is 1 over I? Well, 1 over I is equal to, well, I have developed only the right side. On the left, what you have is cs minus 1 plus I equals to the right minus 1 over I, which is the result of this. And what we are going to do is multiply times I divided by I. So this in the denominator is I squared, which is minus 1, and this cancels with this minus, so in the end, the result of this is just I. Sorry, I forgot here the d, the value of d. C minus 1 plus I plus the value of d. So what you get here is, on the left, what you have is d minus c on the real part, and then plus ci. We add together the real parts, and the imaginary part is just I times c, this. And then this is going to be equal to only I, so that means that we don't have real part. Okay, so that means that d minus c is equal to 0, and c is equal to 1. Because c is equal to 1, then d is equal to 1. Okay, so that was only the part of the partial fractions, okay? So how are the partial fractions? So y of t is going to be equal to the Laplace transform inverse of capital Y. But what is capital Y? Capital Y is this number. But instead of taking the Laplace inverse of this, we are going to take the Laplace inverse of the partial fraction. So it's going to be the Laplace inverse of a over s. What was the value of a? Oh, we haven't calculated the value of a. Sorry. So we haven't finished with calculating the partial fractions. Okay, my mistake. So it's going to be 2. Now, because the value of a is a repeated root, then we cannot use the Heaviside method. Okay, so what should we do? Okay, replace the value here, 2 equal to the value of a, which we don't know yet, s squared plus 2s plus 2. But here you already know the values of b, c, and d. So the value of b is equal to 1, so it's going to be just plus s squared plus 2s plus 2. And then here the value of c and d, 1 and 1, so it's going to be s plus 1 times s squared. And here what you do to find the value of a is just you choose any number of s. any number of s, so you choose s equal to what? Now you cannot choose s equal to 0 because that is the root. So I'm going to choose s equal to 1. You can choose whatever number, but don't choose 1 million or a big number, just a simple number. S equal to 1, so if you replace it here, it's going to be 2 equal to a times 1 times number 1 here, 2 and 2, 4, and 1, 5, and then plus here again 5, and then plus number 1 here is going to be just 2 times 1. Okay, so what is left here? This one is 7, to the other side minus 5, so 5a is equal to minus 5, so that means that a happens to be minus 1. Okay, so we finished calculating the partial fractions, and the partial fractions we are going to find y of t by taking the Laplace inverse of the partial fraction, so that means the Laplace inverse of the value of a minus 1 over s plus the Laplace inverse of b over s squared, 1 over s squared, and then plus the Laplace inverse of c and d. Is going to be c and d is 1 and 1, so it's going to be s plus 1 over s squared plus 2s plus 2. Okay, there is no problem with calculating these two partial fraction inverses. The problem is here. And here what you have to do is to apply the method of complete the binomial. Okay, so let's do that procedure here. I hope I have enough space. So what you have to do is this divided by 2 and then a square. 2 divided by 2 is going to be 1 square, then you have to make plus 1. And you have to compensate this with minus 1. So what you have is s plus 1 over s squared plus 2s plus 1 plus 1 here. Now check this number, and that is the purpose. This is the binomial. So that number is s plus 1 squared. Oh, okay. Okay, so that's it. Now, how are we going to solve this formula? Well, we have the s plus 1. We are lucky. We are lucky on this problem because we don't have to complete the denominator. It's the same. Now this looks like the exponential times the cosine. Okay, so let's find the final result. Y of t is equal to minus 1, that is the Laplace inverse of 1 over s, and the Laplace inverse of 1 over s squared is going to be plus the value of t, and the Laplace inverse of this is going to be plus exponential minus t. This is the minus t cosine of t, and this is the final result, the solution of the differential equation. Okay, so this was just an example on how to solve differential equations. Of course, here in this problem it was easier to me to have 0 and 0. On the homework you don't have that case, so you have to do more calculations. Okay, see you on the next example.